where we talked about congruent triangles, and we said, okay, how do we prove two triangles are congruent? We got to prove all 6 parts are congruent, all 3 sides, all 3 angles, and that took a lot of work and was very time consuming and became very tedious. And so we said, hold on, let's use some shortcuts, and those shortcuts are good. And another one. Keep going. What are the shortcuts for proving triangles congruent? Kira.
Side.
Side, side, side. Keep going.
Okay, side angle side.
Side angle side.
Hypotenuse leg.
Hypotenuse leg.
Oh my gosh, what else is? Can't remember those all.
Angle.
No.
Angle, side angle.
Angle, side angle. One more you missed.
Side.
Got that already? Angle, angle, side. What doesn't work? ASS and which is just if you're a coward and don't want to say ASS, then you would go SSA.
Angle.
Angle, angle, angle. So those are the 2 that don't work. My banana.
We're up, James.
You killed my banana.
We're up.
So wrong. Okay, so angle, side, side doesn't work, never works. Angle, angle, angle doesn't work for congruency. However, you will see that it's one of our shortcuts for what we're going to do here. So if that's what we do with congruency, we're going to do a similar thing with similarity. In that the other day we talked about if you want to prove two triangles are similar, then you need to show that the angles are congruent and all the sides are proportional. And that becomes a lot of work, and so we have some shortcuts. That's what we're going to do today. We're going to use that to solve the following problem. I can get my clicker to work. There we go. Okay, that's you. You're 5'6", and you have a 6'6" shadow, and you're toting a wagon full of math books. What are you, a parrot?
Why not more?
Math books. Are you gonna do that after every sentence that I finish? Finish. That'll get tedious after a while. Okay, so then we've got a flagpole, and obviously we can't just forget that guy. It's the only. I had to find a quick piece of clip art, so I used one where guy's running up the flagpole. Just ignore him. We can't easily measure the height of a flagpole. You're not going to run up the flagpole or climb up the flagpole to measure the height, but we can easily measure the shadow on the ground. So we know you're 5'6". We know your shadow is 6'6". We know the shadow up the flagpole is 125. Find the height of the flagpole, get out your calculators, go man, go. Over again, good job. Dr. Susan. Oh, by the way, make sure you don't make a common mistake. 5'6" is not 5.6 feet.
Wait, what?
Huh?
No, you repeat what you said.
You didn't hear what I said?
I did not.
Why?
That's why I said what.
No, you said wait, what? So am I waiting or am I answering your question? Which one would you prefer first?
Answer
It's not a good way to answer a question. Start over.
Okay, so.
So is not much better. It's still just a stalling device. Think about what you want to say. Take a deep breath and say it.
Do the
We've only
what
got
first.
50 minutes.
Do the what first.
Do the what first?
Yeah, then
Okay.
we can wait.
What I said was don't make the mistake of looking at 5'6" and thinking that that's 5.6 feet.
Oh. Okay.
And as you should commonly be doing with a lot of these problems, when you get an answer, ask yourself a simple question: does that make sense? Which is taller, you or your shadow? Your shadow. So therefore, which would be longer, the shadow or the flagpole? The shadow. So if you get an answer of like 305 feet, you did something wrong. Also, if you got an answer like 1.5 feet, you probably did something wrong. Not a lot of 1.5 foot flagpoles. And it's a word problem, don't forget units. Question?
When it says it's 6 feet 6 inches, is that the dash line or the bottom line?
It's the shadow.
I know which one is that though.
Bottom line.
The bottom
Where do
one.
you find a shadow?
Well, I mean the shadow also like comes down like that.
It does? You see a lot of shadows floating around in the world?
Well, I mean,
Do you
that's-
see dead people? Okay.
That's just how shadows are like made. So
Correct, but you don't
that's-
see them
okay,
floating
sorry.
around in the space, do you?
My bad, my bad. I messed up on the first
I
one.
understand, fix it, it's okay, we're not going anywhere. What do you got? A whole bunch of different answers here. Christian, what'd you get?
105.76.
Can somebody confirm or deny?
Yeah, I got that.
Is that a confirm or a confirmation or a denial? That's a confirmation? We agree? Who got something different? What'd you get?
105.77.
Okay.
Yeah, you're wrong.
He's actually right
Actually,
there.
I got 105.77, rounding to 2 decimal places. We have to look at the next number, and therefore his answer is inaccurate. That was nerdalicious. Christian, I'm sorry for that, first of all. Second of all, how did you do it?
I did 66 divided by 78, and then I just multiplied that by 125.
Whoa, 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 you're firing out numbers I don't see anywhere. 66,
Oh, well, I converted it to inches, so it'd be easier.
all right?
So I did 66 over 78.
So you're 66 inches tall.
Yeah,
Yeah, okay, good. 12 times 5 plus 6.
and then, so I had 66 over 78 is similar to x over 125.
But you were in inches, and the flag's in feet.
Oh boy.
Oh.
Oh nards.
Yeah,
Uh,
69.
Is that okay?
No, that's not okay.
Not talking to you, Tom.
Sorry.
Tom, have you ever heard the term internal voice?
Nope.
Okay, we'll have to talk about that. So let me ask my question then, Christian. Is that okay?
No.
It's not? Yes, it's not, or yes, it's
No,
okay?
It's not okay.
That, so no, it's not means yes, it is. Which one is it?
Whatever what I did is wrong.
So it's not 105 feet tall.
No.
Why not? What should it be?
It should. I'm not sure.
Grace, what do you want to chime in with?
Isn't it like 148?
But then that would make the flagpole longer than the shadow.
No, it wouldn't.
What do you got?
If you, oh, I haven't finished it, but don't you have to just convert 125 feet into inches?
Okay,
So you
And then what?
multiply it by 12, so it'd be 1,500.
okay, then what?
And then, you do 66 over 78 equals x, equals 1,500 over x.
No, x over 1,500. Shadow goes on the bottom, the way you set it up.
Oh, okay.
Okay, so go ahead, finish that calculation.
I don't-
You're done.
I don't have
You're
it.
giving up.
No, I'm not.
Okay, what do you got?
I have 99,000 equals 78x, and then x equals 1,269.23, that's inches, and then I convert it back to feet.
105.77, isn't that what you said you got, Christian?
Yeah.
No, he said he got one of.
Back off,
Yeah.
the internal voice,
5.76.
whatever. You got about 105 feet, right?
Yeah.
Well, you told me that doesn't work, but you got the same answer he got, and he converted it to inches.
Oh.
think it's just.
So he
I
was
think
right.
Trish, you just said
Used
it wrong.
about, wouldn't it be 78 over 66 if it's x over 1,500?
No.
You can do it, remember when we talked about setting up proportions, you can do it a whole bunch of different ways. So let's go back to what Christian originally told us.
So these two.
He said, you did six. Wow. This will take 3 days.
Art.
You did that. Cross multiplied, solved, and you got x to be
105.76.
and those are feet. But Simon said he converted, Simon says. Totally unintentional, that's pretty funny. Anyways, Simon said that he converted everything to inches and did the calculations again. And what'd you get for an answer in inches? 1,200,
69.23.
and these are equivalent. So the question is, why does it work? Notice what happens when I set up a ratio here. These are inches, these are inches, these are feet, these are feet. What happens when you put inches over inches?
It
They
turns
cancel
into
out. It removes the necessity for units. So this doesn't matter any longer. As long as they're in the same units, we're good to go. What won't work is to go 5.5 over 78 equals x over $1.25. Okay. You got to have the same units. This is one way to set it up. He did height over shadow equals height over shadow. Did anybody set it up differently?
your shadow.
You could flip it over. 78 over 66 is equal to 125 over x. You could also do height over height equals shadow over shadow.
That's what
Gives you the same answer. Now, why does this work? This is inches over feet, inches over feet, inches, but we're still going to get an answer in terms of feet. Okay, so it does, across the board, it doesn't have to be in the same units. You don't have to convert everything to inches or convert everything to feet, as long as you keep it consistent throughout the same problem. So if you refer to yourself in all inches, that's fine, as long as you keep the flagpole the same. And whether you convert to inches or to feet, it doesn't matter. We good on that? Get rid of this mess. Now, why did that work? What can you tell me about those two triangles? Matt,
They're similar.
why?
Because
Okay, so let's back up. In order for them to be similar, all the angles have to be congruent, correct?
yes,
What do we know about the angles in the two triangles? What did we assume, first of all?
they're all congruent.
What did we assume about the angles and about the picture? What did you assume about the flagpole?
Oh, it was shorter than last shadow.
What else?
Um,
What did you assume about that angle right
what's
there?
a 90?
Right. We assume the flagpole's perpendicular. We assume that you don't have one leg shorter than the other. Right? Because then your name would be,
One leg stand.
But you would have two legs. It would just
Short leg
shorter,
Steven.
so it would still have two legs.
there are certain moments in your life when you're tested.
I thought we were just throwing out.
Mile 20 on a marathon. You know, they talk about hitting the wall, and you just gotta dig deep and find the strength to just persevere. Teaching a lesson when Tom just said something absolutely absurd that no one is named. What did you say?
One leg stand.
Yeah, there's no one running around whose name is one leg stand.
Well, I thought we were just naming.
It was a simple question. We assume that your legs were the same length, because if one leg was shorter than the other, then your name would be Eileen. I thought for sure you guys would get it. So I've got one pair of angles, but in order for them to be similar, we need 3 pairs of angles. How do we do that?
Well, that's 90 degrees.
Yep. It's one of 3.
Those have to be, it's equal to 180, so those both have to be 45.
Nope.
Oh, because they can be,
It could be whatever you want.
yeah.
We assume that we're on flat ground, so the other 2 angles have to add up to 180 for the angle that goes away from the. I don't know how to explain it. You know where the people are standing?
Yeah.
Yeah, like how the angle goes that way, like the line, and then the 2 other ones add up to that.
He's saying if you were on higher ground, the shadow you cast.
No.
Outer angle.
Okay, or not.
What did
It
you
says
say?
It says it's 90 degrees, so then you
Here,
know
I
it's.
got it.
Yeah. Okay.
Okay, could it be because, so you're assuming that the bottom line is kind of like he was saying is flat, it's like the same line because you're
Yeah.
assuming that you're both on the same flat ground.
I'm with you.
And then the other line, what do you call it, this one,
Yeah, what's that thing called?
hypotenuse.
Hypotenuse.
Okay, so you're assuming that the hypotenuse
job,
is, you're assuming that they're the same because you're assuming that you're staying in the same place and that the sun is casting down from the same angle and creating.
There you go. So the sun is so far away that the angle that it forms is going to be the same. So the angle that's formed here is going to match the angle here. And then the third angle theorem says that these 2 guys have to be congruent. Okay. That's half of what we needed. Right? We got now all the angles are congruent. But in order for them to be similar, we said by definition of similarity that all the sides have to be similar. We can't prove that because we don't have all the sides, and in fact we're looking for the sides. The only things we know is I know that this side is similar to this side over here. I know that that side is proportional to this side over here. And actually we don't even know their proportion. We're forcing them to be proportional to solve the problem. Okay, so we don't have enough information to prove that they're similar, which means that we pretty much cheated on the problem. Do we all agree that the flagpole is 105 feet?
Yes.
Do we all agree that the triangles are similar?
Yes.
Yeah.
That should have been a solid yes too, because if the triangles aren't similar, we can't solve the problem. We don't know how tall the flagpole is, but we all pretty much agree it's 105.76.
6, 7.
Whatever.
7.
Oh, it was 7, 6. My bad, Mr. Reedy. That's
So that leads us to our first theorem, our shortcut theorem, and that is the one that doesn't work. And the one that doesn't, what? It's not a good technological day today. There we go, we did that already. 105.8 feet, rounded to tenths, solve the problem. Angle similarity theorem. Angle doesn't work. Wait a second. Why am I missing an A?
Forgot about it.
Natalie, I forgot about.
The 90 degrees.
I'm sorry?
The 90 degrees.
Doesn't have to be.
Okay.
Kara, sorry.
Well, no, it's okay. Okay, so if 2 of the angles are the same, then you know that the other one is going to be equal as well because they have to equal 180. So.
If you want, you could call it the angle similarity theorem, which is what they called it for years until some rocket scientist said, well, wait a second, if all 3 angles are congruent, then wouldn't you only need 2 because of exactly what she said. Okay. So there it is. If you can prove, and this is the only thing you have to prove in 2 triangles, if you can prove in 2 triangles that they have 2 pairs of congruent angles, then those triangles would be similar. Now, there's a couple mistakes that people make with this theorem. First of all, they forget the tilde, also known as the squiggly mark. Without the squiggly mark, it is assumed that that's a congruency theorem, and we already know that congruency doesn't, angle congruency theorem doesn't work. So you gotta include the tilde in there. Angle, tilde. Or if you want angle, if you're feeling passionate about writing all 3 A's, then by all means, knock yourself out. So that'll save us a lot of hassles. And in fact, that's exactly what we just used. We established a 90-degree angle because we assume that you don't have one leg shorter than the other, and we assume that the flagpole was constructed perpendicular to the ground. And then we have the whole business with the sun, which gives us the other angles. Next one. Side, side, side similarity. Not side, side, side congruency, but side, side, side similarity. If all three pairs of sides are proportional, then the triangles are similar. Emily, take a guess. What do you think's next? Side angle side. Well done. Tom, move your melon, will you?
Yeah, I love that, man.
Thanks, man. Appreciate it.
Anytime.
Dude.
Is this good, or do I need to go down more?
You're fine. Just
Alright.
as long as you're comfortable. I don't want you throwing out your back or traction. Side, 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 we set up one similarity statement, or sorry, one proportionality statement, show that the sides are similar. This one, you gotta do two separate things. We got the pair of angles congruent, 67, 67. Then you have to set up a proportionality statement. 12 is to 4 as 9 is to 3. Or 4 is to 12 as 3 is to 9. And it's worth mentioning that it is side angle side. The angle has to be between the two pairs of sides we're talking about, otherwise you have angle side side similarity, and you know what happens when you use angle side side. For the most part, this stuff is pretty easy if you have two separate triangles like I have illustrated here. You mark up your diagrams, you're good to go. But it does get a little weird when you have triangles within triangles, which we haven't really seen before when dealing with congruency. And I'll show you in a second. Everybody good? We're all caught up?
Yes.
All right. What I'm talking about is something like this. How many triangles in that picture, by the way?
3.
Three.
Three.
Oh, two.
Oh, it's 2.
Two.
That's a
Two.
trapezoid.
Yeah.
There's two.
2.
Bamboozled.
Wow, you tricked me.
Are you, go Malcolm X there on me?
What?
With rock didn't I have Okay, there are two. What's the bottom thing?
A trapezoid.
Are you sure?
Quadrilateral.
A quad, yeah.
No, it might not be, because that
It's not a
is not.
quadrilateral?
No, I mean, it might
is
not
a
be a
quadrilateral.
trapezoid. Might not be a trapezoid.
It might not be a trapezoid?
Because that does not look parallel to
Yeah,
that.
you don't know if
It
it's
doesn't
parallel.
look parallel.
And it's
Oh,
not
there's the key.
specified. It's
Those
not.
can be deceiving.
Yeah, it's not
It might be a
specified.
trapezoid, it might not be. Let's find out, shall we?
Yeah.
No.
Yes, we shall.
Beautiful. Let me see what information I got for you here. Are those two triangles congruent? Sorry, I keep using that word. Are those two triangles similar?
We don't know.
We don't know. What do we need to know in order for them to be similar? All right, I'll live on the edge. Yes, Tom?
You have to know if NP is like straight.
It is straight. I know that.
It is?
Yes.
Like, no, I mean parallel to RS.
Oh, that's a completely different statement.
I mean, you need to know it's parallel to RS and straight.
That's one possible option. What?
Traumatizing me.
Well, hold on, you're putting the cart before the horse. I know where you're going, just hold on to that for a second. Okay, we'll come back around. Okay, so, back to you, Tom. So you're saying NP has to be parallel to RS.
Yes.
And if NP, Newt Puma, is parallel to Raccoon Skunk, then what do we know from that chunk of information?
That gosh, phone friend.
Sure.
Who wants to go? Jalen.
You know that NPSR is a trapezoid.
But how does that help you with the problem?
And therefore?
And therefore,
We just wasted 5 minutes of our lives.
and therefore,
Hey, parrot boy. Shifted into neutral.
and therefore, the diagonals are.
Oh, we don't want to go in that.
Oh.
That's gonna open a whole new can of worms. No, you lost the opportunity to speak. Grace,
Oh.
if, you okay? Took you by surprise there?
A little bit.
If NP is parallel to RS, then what other chunks of information do we get from that alone? Other than the fact that it's a trapezoid.
Well, I mean, since MN and then NR are kind of like the same as MP and PS, you kind of know that it's like the same ratio there, and then you know that it's straight, and then you can prove them congruent since the scale factor is like the same.
Hold on. You just hit the ground running there. Everything you said is accurate, which we'll come back to, but you didn't answer my question.
Oh, I didn't. Okay.
No. If NP is parallel to RS, then what else do we know, Alyssa?
Angle MNP is congruent to angle MRS.
Beautiful.
And then same with angle P. And
Everybody get that? If these two lines are parallel,
We got it.
It's gonna come back
It's
later.
good.
if those two lines are parallel, then this angle has to be congruent to that angle. Why, Alyssa? What kind of angles are those? Corresponding, outstanding. And sorry, I had an extra battery. Battery's not. And therefore, the other one was this one. It is congruent to that one, and therefore, I've got angle, and I'm good to go. I could also use the fact that this angle is congruent to itself, and then could have just stopped there. Okay, Joanna, back to you. What were you saying before?
I was just saying very similar regardless of NP. Maybe not regardless of NP, but like we didn't need to find out how long it was to know the two are similar.
So that whole discussion was for nothing?
No.
Okay. How would you show that they're similar?
So, because MNP and MRS have the same scale factor for their two sides, and then M is the same.
Wait, slow down. It takes me time to process. I'm a little slow.
10 divided by 12 is the same as 25 divided by 30.
What'd you say? 20.
25 divided by 30. How did we get 25?
I was just gonna ask the same question.
10 and 15 and
MR
12.
and MS, you add 10 and 15 and 12 and 15.
Because remember, we have to compare triangle to triangle.
Yeah.
Not just numbers. You just can't fire off numbers from everywhere. This is 5/6. This is.
5/6.
Oh, wow.
Thank you.
You're welcome.
Okay. Now, good. What was the other chunk that you said? So now I have two pairs of sides that are proportional.
They both have M as their top sides.
And like we said before, M is congruent to itself. So what similarity theorem proves then that those triangles are similar? Side angle side. Similarity. Don't forget that tilde. It's really important. Without the tilde, marked wrong.
Wait, so my theory was for nothing?
What?
No, they both work.
No, they both work.
Wait.
Both correct.
Oh, they both work.
Yes, Tom.
You broke on that. You said wait. Say that you can go again.
Oh, you can go again.
Oh, thank you. What was your question?
No.
Okay. So how long's NP?
15.
15?
Hold on. Wait, don't do that. Sorry.
What?
15.
Hold on. Wait, don't do that. What am I not doing, waiting or holding on?
We're done.
Don't do both. So don't wait or don't hold on.
Yeah.
Okay,
15.6.
15.6, how'd you get that?
I did I squared 10 and 12 and 7 equal to the hypotenuse.
But we don't know we have a right angle.
Oh, dang it,
Nor do we know that they are, nor that there's a hypotenuse.
never mind
Risk it.
No.
Hey,
No.
come on,
Risk
I
it.
know it, I
Risk it.
actually know it.
Joanna.
No! Matt, not cool, man.
We're just gonna take 20 more minutes off our time.
25.
Sorry.
We do 25 over 20, which is 5/4, and then it would be 10 over NP. I don't know what that is.
You trailed off there in the end.
Sorry.
What am I doing?
didn't calculate it. It's just, you do 25 over 20, which is just 5/4.
Speaking about taking 20 minutes, 25 over 20.
Is 10 over NP. And then
Okay, so this whole side of that triangle over this whole side of that triangle equals this side of that triangle over that side of that triangle. You can't do 10 over 15, it doesn't work, because 15 is not a side of a triangle, it's a little chunk in there. Cross multiply, you get 8 maybe?
8, yeah.
Is it 8? Okay, we good? Usually angle similarity is the easiest theorem to use, but sometimes, as illustrated in this problem, you don't always have the necessary information, so you got to go with one or the other, side, or side angle, side similarity. In this case, we use side angle, side similarity. Okie doke. One last thing. What's a similarity statement between those two triangles? Go ahead, Matt.
Triangle MNP is similar to triangle MRS.
Mongoose, narwhal, puma.
Platypus. Oh.
Is congruent to angle mouse.
Mouse.
Rat.
I mean triangle mouse, rat, and skunk.
Why not rat? Why not squirrel?
There's mice.
Back off, he's driving the bus.
Why not salamander?
Seahorse.
How about stupid? Oh wait, that's not an animal, sorry. My bad.
Wait, what about magic for N?
Technically that would work, he's an animal.
He's a parrot.
I'm with all animals.
Yes.
Yeah. We're
This is-
okay.
Karma.
We're done.
Wait, where's the moose video?
Where's the what?
Moose video.
What moose
I thought you were
video?
just including them at the end of the slideshow.
Yeah.
Oh,
Are you like a daily
Yeah.
video?
No, I just said
I'll
we
just-
should.
Okay. I'll end the rest of the chapter including a moose video at the end.